Hi folks, we're going to take a look at the solution to number 2 on the Unit 2 assignment extra questions. So I'm actually going to do the second part first. So it asks us to determine when this object is speeding up and slowing down. Okay, so first of all we need to know what information we're given, and what this graph represents is the velocity function. Okay, and in order to determine speeding up and slowing down, we have to consider both velocity and acceleration and look at their signs. Okay, so I'm going to make two columns here. So speeding up and slowing down. Okay. And of course, when an object is speeding up, both the velocity and acceleration are going to have the same sign, and when slowing down, they're going to have opposite signs. Okay, now since I'm given the graph, well, determine the sign of the velocity is just a matter of looking at whether it's positive or negative. Whereas to find the sign of the acceleration, we have to look at the slopes of the tangents. Okay, so I'm going to start in this interval here from about 0 to 0.75. And here we see that the velocities are positive, but if I look at the slopes of the tangents, they're negative. Okay, so opposite sign, which means that that's going to go in the slowing down column. So 0 to 0.75. Okay, it's slowing down. Okay, but if we go into the next section here, we notice that the velocities are negative and the acceleration is again still negative. So same sign, so that's going to go in the speeding up column. So 0.75 to about, I guess, 2.1. The object is speeding up. Okay, going to the next section. Negative velocity, but positive acceleration. So again, slowing down, so union 2.1 to, that looks like about 3.4. Okay. Next section, positive velocity in this whole area here, and in this whole area we also have positive acceleration because the slopes of the tangents are all positive. Okay, so from about 3.4, okay, to this looks like it's about 5.8. The object is speeding up. Okay, next section here, again, velocities are still positive, but now the slopes of the tangents, the acceleration is negative, so that's going to be slowing down. Okay, so here, union 5.8 to about, looks like 7.2, slowing down. And then in this last section here, we see that the velocities are negative and the slopes of the tangents are also negative. And so that's going to be in the speeding up column. So that's from 7.2 to about, well, again here, whether this ends at, it looks like 7.5 or it continues going to positive infinity. Either way, it's positive infinity. We see that it's going to keep speeding up. Okay, and I guess we should be emphasizing here that all values are time units. Now, because I don't actually tell you what the units are, we can't be more precise than that. Okay, so just to recap, you have to make sure you know what information the graph is giving you. Make sure you know how to determine speeding up and slowing down. So it's about looking at the signs of the velocity and acceleration. Okay, and then analyzing the graph as you go along. Okay, so let's move on to part A, which asks us to sketch the acceleration function, which is just the derivative of this function here, and a possible position function. Okay, and of course the derivative of the position function is the velocity. So the easier one is always to draw the derivative of a function. So let's start with that. Okay, so when you're trying to draw the derivative of the function, easiest thing to look for is anywhere where the slopes of the tangents are 0. So those become your x-intercepts to your derivative function. So here we got a horizontal tangent there, and we've got a horizontal tangent there. So let's plot that. These will become the zeros of our derivative function. And now it's all about analyzing how this function behaves. Okay, so if I look to the left here, I see that these slopes are all negative and getting steeper, steeper, steeper. So we know it's going to go down there. And then as we go here in this whole section, the slopes of the tangents are all positive. So we see that the tangents are getting steeper, so more positive. And then somewhere around here, they start to get less positive. So this is going to become more and more positive, and when we reach around 4, suddenly we see that the slopes of the tangents are getting less positive, so they're going to come back down until they reach this slope of 0. And then on this side, we see that the slopes are negative and getting more and more negative. Okay, so our graph is going to look something like that. So what I might suggest doing is, sketch it really lightly with a pencil. Okay, and then from there, maybe take a pen, okay, to draw it a little more clearly. Okay, so okay, and this is going to go on. Okay, even though this will end at t equals 0, we can't see it on our graph. Okay, so there you have it. So in order to graph a possible position function, in other words, to go backwards here, well, now we're going to have a different starting point. Okay, what I want to look for is where my derivative, so let's just be clear that this represents a at t, okay, the derivative of the velocity function. Okay, so what I want to look for first is where is my derivative function equal to 0. Okay, so the first time it's equal to 0 is over there. So that means that this value, my original function, in this case your position function, is going to have a horizontal tangent. Okay, and if we look to the left and right, we see that the slopes of the tangents are going from positive to negative. Okay, so if you have a horizontal tangent and positive on the left, then hey, it's going to have to be coming down so that the slopes of the tangents are positive, and on the other side, negative going down, so the slopes of the tangents are negative. Now the reason why we say one possible function is that there's many, okay, because the only thing the derivative gives us is the shape of the graph. Where I start doesn't matter. Now I'm going to start a little further up just so I don't get too confused with the graph that I already have. So I'll start up here. Okay, so there's the point at which I have a horizontal tangent, and I know I have to come down, okay, on this side, because here I need my slopes of tangents to be positive, and on the other side, it must mean I have a maximum there, because now my slopes of tangents have to be negative. Okay, but let's see what's happening here. We see that they're going negative and they're becoming more and more negative. So they're getting steeper and steeper and steeper. My slopes of tangents are going to be getting steeper, steeper, up until this point where they're still going to be negative, but they're going to start getting less steep. So what I'm going to do is I'm going to draw a little dotted line here to help me draw it out. Okay, so I've got my graph here. Okay, and here I see they're going to be getting steeper, 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 and then at this point here, they're going to start getting less steep until I get to my next horizontal tangent. So at this point here, I'm going to have my next horizontal tangent. So now when I draw it, notice how they're getting less steep until I reach another horizontal tangent. Okay, on the other side here, now the slopes of the tangents are becoming positive. So they're going to come back up. So I have positive tangents. And what are they going to do? They're going to keep getting steeper, steeper, steeper till I get to this point here. Okay, so here, steeper, 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 steeper. And then when I get to this point, they're still going to be positive, but getting less steep until I reach, and let me draw my line up here, where the slope of the tangent is going to be horizontal. So now I have to draw them so that they're getting less steep until I get to my horizontal tangent. And then at the end, they're going negative again. So this is now going to come down. Okay, and not surprisingly, okay, this looks a lot like a quartic function whose derivative looks like a cubic function. Okay, so as before, now we'll take this line and we'll just draw now a nicer curve. Okay, bring everything together. Okay, the idea here was we're not looking for precision. What we're looking for is a correct shape. Okay, And there you go. I'll put an arrow here, but notice how I'm not putting an arrow there because at 0 we're stopping. Okay, so just to recap, when you're looking for the derivative of a function, you start with where the slope of the tangent is 0. Okay? When you're going backwards, you're given the derivative and you want to find the original function, you start where the derivative is equal to 0, because that tells you where you have a horizontal tangent.